In session 1 of the FIJI for Quantification workshop, we will cover demonstrations on FIJI setup, Activity 1 will ensure that we've got FIJI set up correctly for this workshop. To ensure that our FIJI is set up properly for the workshop, we need to go to Process, Binary, Options. Make sure that your iterations is set to 1 and the count is also set to 1, that we've ticked both black backgrounds and pad edges when eroding, and make sure that our EDM output is set to overwrite. You can also go in to Edit, Options, Colors, and set our foreground, background and selection. Finally, we can go to Plugins, Utilities, Monitor Memory to keep track of our memory as we go through the workshop. If I open up an image, you'll see that we get a little jump in memory. But if we close the images, you'll see that that memory isn't necessarily cleared out. The data that we're using in the workshop isn't very large, but if you have large data, it's a good idea to clear out your memory. You can do this just by clicking on the bar here in FIJI, and that will drop down your memory usage. Activity 2, Line Analysis, measures the intensity across a line region of interest. To perform the line analysis, we are going to go into the line analysis folder and open up the GAMS green, GAMS red and GAMS TIFF images. So drag and drop all three. So in this example, we have a malaria parasite with a filament that runs from one tip all the way down to the end. What we want to do is analyze the intensities running along this filament. So in this case, we're going to use the line tool, and if we right click, we're going to use the segmented line tool. I'm going to do this on the merge because it's a bit easy to do this across two channels. So left click, drag, and click as you go as you're drawing along that filament. I'm going fairly quickly, but when you would do the analysis, obviously would go fairly slowly. Maybe you could zoom in to give you a little bit more resolution on what you're trying to do. And then when you're at the end, just double click. Okay, so now we've drawn our filament. What we want to do is apply that to the green and red channels over here. So if you remember, we're going to Edit, Selection, Restore Selection, Control-Shift-E, and that's restored it onto here. We can click on the red channel, Edit, Selection, Restore Selection. Again, Control-Shift-E. You don't need to use the drop downs, you can use the shortcut. Once you're happy that you've got your line, you then want to plot that. So to do that, we're going to go to Analyze, Plot Profile, which is Control K or Command K on a Mac. So this gives us our line intensity along that line that we've drawn. It also gives us a little table here of X is distance in pixels in this case, and Y is our intensity on the 8-bit scale. If we want to, we can go in and save that out as a CSV file. So we can do that for both the green and also the red. And we can see that we get very different profiles in the green channel versus the red channel. There are a few optional items if you want to go a little bit deeper in activity 2. So for example, you can plot this line and draw it as an image, as a straight line. We can change the width of the line that we're doing the analysis over. So at the moment we're drawing this with a line width of 1 pixel. If we were to increase this line width, then that might average out some of these jumpy areas within the graph and give us a little bit more smooth data. Feel free to go through the optional items if you want to. Activity 3, thresholding. This allows us to identify areas in the image based on their intensity. Activity 3 is thresholding. To perform this, we're going to open up the kidneygreen.tiff image. And what we want to do here is work out or highlight the regions which are brighter within this image, and we're going to use thresholding to be able to do that. Okay, there are lots of different ways that we can do thresholding, and the first method I'll show you is using an auto threshold. So we're going to go into Image, Adjust, Auto Thresholds. Now within FIJI, as I mentioned, there's lots of different methods. These are all mostly published, which allow you to automatically highlight regions within an image. So let's try them all. What we're looking for are white objects on a black background, and we're going to show the threshold values in a log window. Now if we click OK, this is applying each of those threshold methods to that image, and it's giving us a little lookup display of what each of those looks like. So what your job is to go through each of these different methods and try and work out which one you think highlights the structures you're interested in the best. So probably not this one, not that one, and not this one, but something else. Maybe this one here, or one of these ones down here. It's really up to you in terms of what you're trying to identify. Now the trick here is to work out what this method is. If we're choosing this one, you can see there's a tiny little piece of writing here. If we zoom in, you can see down here, we can use the pen tool to move it around. So it looks like the method that we want to use is one called isodata. Okay, the other trick is just to count them. So method number 1 is the default, method 2 is Huang, method 3 is Huang2, intermodes, then isodata. Okay, so you can see them in order down here. So we're going to use isodata, and they're suggesting a threshold of 49. Okay, so let's go back to the original image, make sure this is the one that's selected, and then we're going to go back and actually apply that threshold. So again, Image, Adjust, Threshold, or Control-Shift-T. Brings up this window here. And normally we use the red function for this, and you can see we're doing an inclusive threshold, so we're highlighting anything that's above 49 pixels, 49 grayscale values, so 50 to 255 is highlighted in gray there. And the important thing is at this point we don't want to hit apply. Okay, so if we hit apply, we're going to turn this into a binary image. We just want to use the threshold to identify the regions that we're interested in. Activity 4, area of stain. In this we're going to use a simple threshold to identify regions and quantify the percentage of the total image. Next thing we're going to do is work out the area that we've highlighted as a proportion of the entire area, and also just in microns squared as well. Okay, so we'll leave the threshold there, If you don't have this image up, then you'll have to go through the previous activity to get the threshold. And next thing we're going to do is go to Analyze and Set Measurements to tell FIJI what measurements we want to read out. In this case, let's read out area, integrated density, mean gray value, and area fraction. Really important button here is limit to threshold. Otherwise, if we don't click this, it's going to read out the entire image, so not just the thresholded area. Now we click OK. That's set the measurements that we're going to read out. And now we can go to Analyze Measure, or Control M, or Command M for Mac. That will now read out that area. So area in microns squared, mean intensity, your integrated density, the percentage area that's been highlighted, so 15.8% of the image has been highlighted underneath that threshold. If we've missed something out, we can always go in, right click on the results, go to Set Measurements, change whatever parameters, but then we need to run that measurement again. Activity 5 is cell confluency. Again, we'll use a simple threshold to quantify confluency. For this activity, we're going to open up the BPAE folder and open the BPAE green image. Okay, so that's our image here. We want to work out, again, the percentage area over the entire image, giving us an idea of confluency. So we're going to set the threshold again, so image, adjust, threshold, or Control-Shift-T. Okay, here we can either change some of the settings or manually change this. Sometimes in this case it's useful to use the over-under. So the blue actually shows the background, which is what we're not going to quantify, but gives you a better visualization of what you're covering and not. Okay, so I'm going to sit somewhere around 28. Again, we're not hitting apply here because we don't want to create a binary image. And again, if we're happy with the measurement settings we had before, then we can leave those. Otherwise, we need to go Analyze, Set Measurements. But if you are happy with those, go to Analyze, Measure. And again, we're getting, in my case, 63.8% of the image is covered with those cells. Activity 6, nuclei counting. In this we'll use Analyze Particles to count the number of objects in an image. For this activity we're going to continue in the BPAE folder, but we're going to open up BPAE blue.tif. Okay, so in this example we're going to use nuclei because they're really nice structures to find, but you can use this to find any type of objects. Okay, so the first thing to do is to again create a threshold. So we want to identify just the objects that we're interested in. Image, adjust, threshold. Let's go to red. And something like that is probably fine. 79 to 255. In this case we want to create a binary image, so we're going to hit apply in this case. Okay, so this is now changed. If you look at the intensity values up here, it's 0 in the background and 255 on the objects, so this is our binary image. We've only got 2 levels of intensity information here. One thing you will notice is that a few of the nuclei that sit together have been joined up, so this could be counted as one object, so we want to try and separate those out. To do that, we're going to use Process, Binary, Watershed. And what this uses is the shape of the objects to try and separate those out. Okay, next thing we want to do is to actually count these objects, and we're going to use Analyze Particles for that. So we want to go to Analyze Particles, And we're going to do a little bit of filtering here, so we're going to exclude anything. Let's do pixel units, 100 pixel units to infinity. We're not going to filter based on circularity. And we want to show outlines. We're going to exclude anything that's touching the edges, so we can't be sure things that are touching the edges, whether they're 1 or 2, and if we're having readouts like area, then it's very dangerous to include anything that touches the edge. Let's have a look. We are going to display results and have everything else off. So display results, exclude on edges. Once we click OK, that gives us a readout that we have 70 individual objects. And it also gives the set measurements that we have already, so area, mean, integrated density, percentage area, or integrated density. So it's individual readouts for each of those objects. And we've got the outlines with each of those objects numbered. Now if I go back, I go back to here again, I might analyze the particles again. If we include the summarize button here, we click OK. It gives us our outlines, it gives us our individual data, but it also gives us a summary. So it's telling us we've got a count of 70 objects within that image. This is the total area, this is the average size, etc., etc. And again, both of these tables you can file, save as a CSV, and the output here again we can save as a TIFF file if you want to use that later on as well.